two components as the main component of the Hadoop, that is the HDFS and MapReduce. And whatever the HDFS is related, that is related to the storage, and MapReduce is related with the something that is processing of the stored data. So we have seen the HDFS, and what are the different configuration of the HDFS is required for running the program, we will see later, means in the upcoming classes. For now we are going to start with the second topic, that is the MapReduce. And what actually the MapReduce is, we have discussed something about the MapReduce. The MapReduce is something that is related to the storage, means something the processing of the data that we have stored in the HDFS. So before going to the introduction of the MapReduce, we have one picture that is on the screen. You may be able to see what is that picture. So when we don't have the concept of the Hadoop and the MapReduce, earlier when we have the large data set like this which you are seeing on the left hand side, that data is going to be first splitted into different blocks, and for each splitted block there will be a separate grep command will be performed on that, and whatever the result coming from that splitted block will be finally displayed as the calculated one after joining all the results. Okay, so in this what is happening in this, the main problem is that when you are going to have a very big amount of the data, so first problem you will face about something that is the splitting of data, means each and every time you have to split the data in a separate block. So what are the different problems the peoples are facing for that traditional way is, some of the problems from that traditional analysis is here, as you may be able to see it on the screen. That is the something known as problems in the traditional way analysis. So what are the different traditional analysis problems we are facing? So anybody having any idea what are the different problems when we go for the traditional approach? Any of the people having? Hello. So any of you might having some means idea what are the different problems we are facing during the traditional way approach? Can anybody just highlight some of the way? So we can say that our first problem is the critical path problem. What is that critical path problem? It is something that is related to the time and the performance of the job. Okay, when we are going to have a large data set, we have to do certain performance for related to our MapReduce work. If we didn't get our response from that MapReduce program on time, what will happen? We will have a lot many problems. Okay, and what are the different problems we will have? So first, that our processing time will be slow. Along with another problem is that we will not able to get the correct output at the correct time. So it will be simply wastage of using that. So how to come out of this problem? We have the solution in the MapReduce. So first problem is the critical path problem. What is this problem? It is just simply the amount of the time taken to finish the job. Okay, means if we are doing the job, it should be started without any delay. Yeah, you have asked that if our processing will our blocking of data will be not done correctly, then what will be the means output? Then at that time we will not be able to get the complete output or the correct output. So there will be, so at that time the people might be able to get confused that from which block we are not getting the particular data. Okay, so for that purpose we have the concept of the MapReduce. What is that MapReduce? See the MapReduce is simply the programming model which is designed for handling the HDFS cluster. Okay, and we know that the HDFS is totally written using the Java programming. So this MapReduce is also for the people who is having the knowledge of the Java, because if you don't have the knowledge of the Java, you will be not able to write the MapReduce, and you might be not able to understand also about the MapReduce programming. Okay, so the person who is not having the knowledge of Java will have some alternate method for this MapReduce. What is that alternate method? That we will see after the completion of this MapReduce topic. So for this particular time, we need that what is MapReduce. So the MapReduce is simply the programming model designed for processing the large data set that are stored in the SDFS cluster. Now, what is inside the map and reduce? So inside the map and reduce, we have the two functions. The first function is the map and second function is the reduce. Only two functions are there to complete all the processing work of the MapReduce programming. And this MapReduce is same as the Google what the Yahoo people has implemented at the later. So what are the different operations which are going to be performed inside the map and reduce? So there are n number of the operations that are going to be performed inside the map and reduce. That is the internal part of the MapReduce. So that splitting of your data block is also the internal part of the MapReduce. And for splitting, we have the one function, that is the inbuilt function of the MapReduce, that is known as the partitioner. After that partitioning work, it will be shuffled. So shuffling is also one of the step. Then after that, for the final output from the MapReduce, we have one more step, that is known as the sorting. And from after the sorting, we have the next step, and the final step for the MapReduce function is the join functions, because we can't be able to understand what are the different outputs that is splitted into the different blocks. So all the outputs are just joined together, and then it will be given the output of the map function. Okay, so how the data is going to be implemented in the case of the map and reduce? So in the case of the map and reduce, whatever the data we are going to give, it will be taken together in the form of the map and key and value pair. So before going for that key and value pair, we have to understand this MapReduce high level diagram, which you are able to see it on the screen. So here what is happening, we have our own problem, that is the application, which are going to be introduced, going to be the input of this MapReduce function. So what will happen of this problem? So as I told you that it will be just splitted into different sub blocks by the partitioner function. Okay, now here we can see that our problem is divided into sub problems, that are the 4 sub problems. And what happening to each and every sub problems? So each and every sub problems are going to be solved separately. So if we have the 4 sub problems, then we will get 4 output from the different problems. Later on, whatever the output, that is the solution we are getting from our sub problems, that will be combined together using the combiner function, that is also the internal function of the MapReduce, and it will able to produce you the solution for the map concept. Okay, so it is something that is the dividing and then again joining. So is there any confusion in understanding this diagram? Any one of you, if you are having any confusion, just let me know.
Yeah, I have.
Yeah, tell me.
Hello?
Yeah, tell me.
Yeah, what is that problem? What is the problem, sub-problem? What is that actually? Can you give me
Yeah, this problem, suppose if you are going to write any program for the MapReduce, okay, then you might be able to complete that program. After the completion of that program, means if you want to run that program, suppose if you have the program for the word count, okay, means there will be one file will be there, inside that there will be n number of the blocks. Okay, so that problem for the is known as the word count, and here the same problem is here as the input. Now that word count problem that is present in the text file, that will be splitted first, and then for each splitted block we will get certain solution, and later on that solutions will be joined together to give us the number of the words present in our txt file. Now it's clear, or do you have any extra questions?
Yeah, clear.
It's clear?
Yes.
Yeah. So what will happen after this joining? What will happen to joining? So one person has asked what will happen to that join. That join is not same as the reduce. That reduce is will give you the final output, and I told you that in the map reduce case we will have two functions. First function is known as the map and second function will known as the reduce. So here only we are seeing that after the completion of the mapping, what are the map function, what are the output we are getting as a solution, this solution will be again sent to the reduce function, okay, and then from there we will be able to get the output. Okay, so this joining is not same as the reducing, it's almost same, but reduce function is separately there, that will give you the single output. For this joining we have the one combiner function, okay, and reducer is the another function. Is it clear? Hello,
Yeah.
is it clear?
Clear. Clear.
Yeah, the same thing is you may be able to find it on the screen that MapReduce divides the work into small parts and each of the parts will work parallelly on the cluster, okay, and then whatever the output we are getting from that cluster will be sent to the reducer function. And I told you that the MapReduce function will work on the key and value pair. So now on the screen there is one diagram, okay. On the very left hand side you may be able to see this, that is the input data. What is that input data? So that input data may be your file which you are going to take the input, okay, and after that this input data it is going to be divided into two nodes, first node and this is the second node. Here the same statement is written, that is the input data is distributed to nodes, okay. Now what will happen? For each and every node a separate map function will be performed, okay, and from the after the performing of this map function whatever the output we are getting that will be again shuffled, and how this shuffle is working we will see in the upcoming example. So the output of the map function will be shuffled and it will send to the reducer, and from that reducer you will get the output, okay. Hello, is it clear?
No, not completely. I have a couple of queries. So,
Yeah, tell me.
can you go to the
Yeah, this is
previous
the
slide?
yeah, this is the slide.
So, how does it look like after passing through map function? I mean, I don't have any idea. I mean, how does the data look like? I mean, can you give the example over there? So,
Yeah, in the upcoming slides we have the example for that one, okay. Just go through that slide,
okay.
and then if you have the still confusion we can go for the clarification, okay.
Okay, great.
Okay.
Thanks.
Shalini, do you have any problem in this one? Hello, Shalini. Okay, then we have to move inside the next topic. So here we know that we have the some in our concept of the MapReduce or the SDFS we have one master and there will be n number of the slaves. So on this very diagram you may be able to see that this is the client who is going to use the map and reduce function. So from this how they will be able to use this map and reduce function? So first time they have to contact with the job tracker, and this job tracker will have the information about the different task trackers, and this task tracker information will be given by job tracker to the client. Then after that the client will contact to this task tracker, then only he may be able to get the completion of his work. So that will be clear with this upcoming slides. Yeah, so I told you that the map and reduce both functions are working on the concept of the key and value pair. means for the mapping we have also sent the input in the form of the key and value, and from this mapping we will get the output as the key and value, and the same output of the map function. Yeah, hello, that mapping function output will be sent to the reducer function. So how that will be sent, Adim?
Yeah.
Are you able to see one diagram that is on the screen right now?
Yes.
Yeah. So see here, this is the MapReduce function. Okay. Whatever the data we are going to give the input to this MapReduce, that will be also in the form of the key and value. So how it will be performed? So on the right hand side, you may be able to see this diagram. Here, this is my mapping function. Okay. Whatever the data, it is in the form of the key 1 and value 1. Okay.
What is key 1? I mean, what it contains?
It will contain some
key
data.
1 mean what?
Okay. If you are not able to understand, just see this example. One example is in your screen that you will be able to understand how it's working. Wait 1 minute. Yeah. Now you are able to see one slides on that screen.
Yeah.
So here what is happening? Here this is our input. Okay, and our input file, this is our input file which contains certain words. Okay, these words may be repeated or not repeated. Okay, this is our input file which we are going to send to the mapping function. Okay, now first time what will happen? This file will be splitted into 3 blocks. Okay, as you may be able to see that for first line there is a first block, for second line second block, third line third block. Okay, so your input.
One question here.
Yeah.
Yeah, just quick question. So input file, let's say input file is called A. Okay, I'm naming it is A. So after splitting it, it is A1, A2, A3 or what? I mean A1 plus A2.
It will be
A3 equal to A.
Yes.
Okay, it's not like the input is A, means the first splitted document is A, the second one is, it's not copy of that input, right? It's not copy.
It's not
just
copy. Simply splitting. Okay, means it is further divided into three blocks. So this is the first. This figure and this column will indicate you the splitting of your input file. Okay. Now here from this one, what will be sent to the shuffling state? It will be in the form of the key and value. How it will be divided? So see here, this block is having 3 words. Okay, and here there is no repetition of any words. So all these words will be now again sent to the mapping function. And what is happening here? What is happening here? Your first word, first word 1 means it is occurring only one time, second only one time, third one only one time. Okay, means whatever it is the block, it will be just listed. Okay, now from the second block also same thing is happening, third block also same thing is happening. Now this is our mapping. After that I told you that we have one function that is known as the shuffling. What is that shuffling means? Shuffling simply here means that whatever the common words will be taken together. Okay, so here beer is present, here there is no beer, here beer is present. So these two will be taken into one block. Okay, then our next word is the car, then deer, then river. All are taken together in a list. Okay, now from this shuffling step, whatever the shuffling output of this MapReduce will be sent to the input to the reducer function. Okay, here you may be able to see that beer occurs 2 times. So the beer and value is 2. Car is 3. Something like that. Okay. So this beer is the key and 2 is the value for that. Okay. Now your key and value pair is clear or not? And this now all this output of the mapping function will be sent to the reducer function, and from that reducer function we are getting this final output. That is, beer occurs for 2 times, car 3 times, deer 2, and river 3. Okay, this is the totally concept of the shuffling and sorting. Is there any question on this one?
So yeah. So the results will come to the job tracker, right? The results.
No,
Who will go to get to know the results?
the job tracker is the master one. Okay, he has only duty
Okay.
to give the orders. Okay, not to do
Mhm.
any order, means any work. All the works, whether you are going to read the file or write the file, that all works will be taken by the task tracker, that are slaves. Okay, job tracker has
Okay.
only one work, that is to give the order to the clients.
Yeah.
Okay,
Yeah. So all this sort of work happening inside the slab, right?
yeah,
Nodes.
that is the data nodes or the task tracker. The same thing you may be able to see it in the figure, that is how the map and reduce is working. Now you have seen the problem and this is your only diagram. Okay,
So reducing also happening inside the node. Am I right?
the mapping and reducing all will be done inside the data nodes only, not on the name nodes.
How two data nodes present in two different locations get to know that this reducing, I mean the reduce results is coming out in node 1, which is present in different server, and node 2 is present in different server. So how they are communicating with
No.
each
Who
other?
told you that the one node is present at different server? All the nodes will be present on a single rack. Rack you have done the,
Okay.
okay,
Yeah.
means whatever the output of the first one, the map function
Hmm.
output will be given to the input of the reduce function first. Okay.
Okay.
So that is the concept. Now here you can be able to see that MapReduce simple steps. So here the same thing, MapReduce emits the key and value pair, and that will be after sorting and shuffling will be sent to the reduce function, and from that reduce function you will be able to get the output. Okay.
Hmm. Okay.
Okay, be online. Hello. Just a minute. Hello Ajim. Hello.
Yeah.
Yeah, that message is not for you, for the others. Okay.
Yeah. Yeah.
Because others are not responding, so
Actually,
yeah, tell me. Hello Ajim.
uh, yeah, actually, because my name is not Azim. My name is Asim.
Oh, okay, no problem, because this is the name first time I heard.
Okay, there's no
Okay,
problem.
okay then. Asim na?
Yeah, Asim.
Okay. What does it means?
Asim means unlimited,
Oh, ho, ho,
infinite.
ho. Oh, no, I have the so many friends who have contact from the Odisha, but this name is first to me.
Okay, okay,
Okay,
yeah.
no problem.
No.
Hello.
I don't know, I just lost you. You said hello and then I did, and now I can't hear you. Okay. Yes, sir. One more thing. Can you please tell me about this release again? So for math, there'll be 5. Okay, so the time.
Depend upon you. Okay. Yes. Yeah, that's your responsibility. How many reducer you want, you can do. If you want. Okay, that is the example we are on the screen right now. We are going to discuss. Okay. Hello, Azim. Hello, Asim.
Yes.
Yeah. So there was a confusion in between that one. So we are doing that work. So we see the map and reduce. We have seen that how the mapper is working. So this is the simple mapper working. The same thing is also applicable to the reducer. Means whatever the output you are generating from the mapper, that is in the form of the key and value, output of the mapper will be taken to the input of the reducer. Okay. So now we have one problem on the screen. You may be able to see how the map and reducer should be working. Are you able to see that?
Yeah, I can.
Yeah. So see here, we have splitted our data into three blocks. First one, second one, and third one. Okay. And for each and every block, there should be a separate mapper function. So we have 3 mapper function here. Whatever the output we are getting from this mapper function, that will be sorted and merged together. Why merged together? Because here we are using only the 2 reducers, means single reducer. So whatever the whatever the output of this mapper function will be, if there are 100 also, that will be merged together, and as a single file it will be sent to the reducer, because here we are making use of single reducer function. Okay. Now the same work we can do it using the 2 reducer also. Here the 2 reducer is there. Now up to this mapper we have the same 3 mapper function for 3 splitted blocks. Whatever the data we are generating from this mapper function, that will be grouped into 2 forms. Okay, now how that will be made? So for that we have one concept, that is the, suppose you have to group the words that is starting from A to Z. Okay, now if you have single reducer, you can directly write for A to Z. Now on the screen you may be able to see that we are using here the 2 reducer, means the output should be divided, output of the mapper should be divided into 2 groups. So words starting with the A to some point in the middle, that is the M or N. From A to M, whatever the words starting from A to M will be taken to one reducer, and whatever the words starting after the M to the Z, that will be merged together for a second reducer. I hope this is clear, na? Is this clear?
Yes, clear. So one question can I ask?
Tell me.
Yeah. So yeah, what kind of data that you are splitting here? I mean,
whatever the data if you have, you are giving. Suppose if you are giving the one.
No, I'm not. Yeah, I'm not going to consider the text data. So text data only you can count the key value pair, right? So if it's certain different kind of data, can you give any
other example?
One more example?
Yeah.
Real time.
So real time example is that now I will assign you one work. Okay, go and find out the maximum and minimum temperature from the last 10 years. Okay, how you will find that? How you will find?
Sorting.
Sorting. Which data you will sort?
Data.
How, from where you will get that data? So that data may be available to our something environment or the natural climatic control board. That data will be available. Okay. Hello.
Yeah. Yeah.
So suppose you are taking the data from that board, that is the climate control board. You are taking the data. Now this is not the word count, but here this is the a real time example for that mapping and reducer. Whatever the data you are taking from that climate control board, you will take that data, and that data will be now your input to the mapper and reducer function. Okay. Hello.
Okay. Yeah.
Yeah. So from there now you are calculating the maximum and minimum temperature. It's clear?
Yeah.
So this diagram is explaining the same thing with 2 reducer. How it's working? There may be a question. So we know that there are some partitioner function, combiner function, that are the all inbuilt function of the MapReduce. Okay, this is the only concept of the map and reduce, means how map and reduce is working. Okay, now after this concept of the MapReduce, we will see certain features of the map and reduce. So what are the different features of the map and reduce? What are the different benefits of the map and reduce function? Could you tell me some features? Apart from the features which I have mentioned in the slides, do you have any idea what should be the different features of the map reduce function?
I mean, it reduce the. I mean, it will give you the unique numbers, right? I mean, let's say you are analyzing any sentimental analysis. Okay. So. So
it should be something like that. Yeah, it should be some economical, if okay, and it should be also easy to use. It should be simple to understand, something like that. Okay, so that all are the benefits that are available in the map and reduce. If you are not using the map and reduce function, what will happen? Your data size will also grow, and your problem will also grow. Okay, there will be lot many problems you will face. So for whatever the different problems you are facing from that map and reduce, that if if you are not using the MapReduce, the same problem will be grown, means there will be n number of the problems that sometimes it will be hard to maintain, sometimes you may be get confused where that error is occurring, something like that. So all that problems has been solved. Okay, that are the problem of the traditional way, and that all the problems have been solved in the map and reduce function. And here we have certain benefits or the features of the map and reduce. On the screen you may be also able to see one feature, that is the scalability. What is this scalability means? Simple, which can be measured. Okay, that is the scalable. Then we have the next feature, that is simplicity. We know that what is simplicity. Third one is the ease of use, means it should be easy. Its working and understanding should be easy, so that we can be easily able to use that map and reduce. See here, the persons who were asking the problems about the map and reduce, where the map will be a job tracker or the name node will be stored, and how that name node be able to contact with the task tracker or the slaves. So on the screen we have one figure that is on the right hand side. Are you people able to see that figure?
Yes.
So see on the top, this is the top, that is the first part is the master. Here the name node and the job tracker will sit. Okay. Then on the bottom side we have different or the n number of the data nodes or the task tracker or the slaves. So whatever the slaves associated for this block will be controlled together from this node only. Okay. And these
nodes are, yeah, I have a question. So these nodes are placed in one rack, right? So
it may be placed in one rack, two rack, three rack. Okay, then a question may be arise that how the name node be able to understand. Okay, so that all will be understand by their address, means on which rack it is placed. Okay. Okay, that is the addresses of the data nodes. So I think this is the mapper and reducer function. You can be easily understand by seeing the diagram also. There is no extra configuration here. This is the only architecture of the map and reduce. Here whatever the picture we have seen and how it's working, the theoretical explanation is that the very big data converted into splits. Okay, and we know it very well, so there is no further explanation for this is required. Now splits are processed by mapper. It's okay, fine. Whatever the data we are going to split, on that mapper function will be applied. Then after that, in the case of mapper only, we have certain partition functions to give the output of the mapper. Then whatever the output we are getting from the mapper will be sent to the reducer to get the output. Now Asim, you have asked what are the real-time example of the map and reduce function where it is going to be used. Okay, so you might be able to see some fields on the screen where the map and reduce function is going to be used. Are you able to see that?
Yeah, it's my familiar word, forecasting and analytics.
So what are the weather forecasting work that are using the concept of the map and reduce? Second one is the healthcare, because nowadays there are a lot many data generating from the healthcare department also. Okay, then we have the ONGC, that is the oil and gas industry, that is also using the map and reduce functions. This diagram is not important. The whatever we have just seen before, the same thing is explained in this diagram also, and this diagram is also doing the same work. Okay, from top to last there are different diagrams for the same function and same explanation. I have added all the diagrams. Now we have to see one map and reduce functions, how that is running. Okay, means what are the different functions we required for the map and reduce programming. See on the screen there is a very complex diagram. You might be get confused what this diagram means to you, but once you just have a glance on this diagram, you will be able to clearly understand. Just for a minute you can go through that diagram. Is it visible?
Yes.
So on the very left top side, what is happening? This map and reduce function is there. Okay. On the client node, we having the map and reduce functions. Very first step is that when we are going to run this map and reduce program, simply we are running the map and reduce program. Then what will happen? It will contact to the job tracker or the name node. Why it will be contacted? Because on the job tracker only it will be able to get one ID. Means for each and every job we will get one ID. Okay. Then what is happening? From same time when this job is getting one ID, that is the job ID, at the same time it is the copy of the job is stored in the HDFS. Means whatever the data we are going to process, that will be a copy of that will be also stored in the HDFS. Okay, that is our step 3. Now what will happen after the storage of this job on the HDFS? The same job will be submitted to the job tracker. Okay, whatever the different analysis we have to do, that first this it will initialize all the jobs at the job tracker, and remaining work will be done by this task tracker node. There is no extra work on this job tracker node. After initialization, it will be sent to this job tracker will send the job to the task tracker. Whatever the task is there, it will perform on the data nodes only. Okay, and after the performance of this data means work, the output will be stored to the HDFS. Okay, and here on this 7th point, you may be able to see that this is written as a heartbeat. What is that heartbeat? Last class we have discussed about something that is a heartbeat. Are you able to remember that one?
Yeah, I mean the response, I mean tracking
yes,
those data nodes.
Yes. So I told you
whether
that
they are working or not.
For each and every work, a separate 3 copies will be generated. Means it will be stored at 3 different locations. So if this first location will not be able to produce the heartbeat after the 3 seconds, then this job tracker will wait for again next 30 seconds. In that 30-second interval, if it is sending one heartbeat, then it's okay. Otherwise the same work will be given or been used by the next node, that next data node. Okay. So
what is that child JVM?
So I told you that the MapReduce programming is in the Java. Okay, and for running the Java we need the JVM, that is the JVM and related to the Java. Okay, so when you go for the Java, you will be able to understand what is JVM and how it's working. For simple understanding for your side, just we are saying that the CPU is the heart of the computer, right? The same way this JVM is the heart of the Java programming. Means for the compiling, for running, each and everything will be taken care by this JVM only. Okay. Hello.
Okay.
Yeah.
Yeah.
Now for your understanding, just remember the points only, that JVM is the responsible for doing all the works. Then this is in the case of the MapReduce 1, that is the HDFS Hadoop 1.1 version. That we have the MapReduce version 2, that is known as the Yarn. In that some extra materials has been inserted, but in our industry people are not successfully familiar with the Hadoop 1.0, and they are still practicing on the Hadoop 1.0 only. So whatever the data, whatever the work you are getting, means some example you are getting from the net or some any other books, that will be also in the Hadoop 1.0 only. There is no example something for the particular for the Hadoop 2.0. Okay. So when we at the last we can see the MapReduce 2. The same thing. See this figure you are able to understand that this client will have the MapReduce program. When it will run that program, it will contact to the job tracker, and that job tracker will simply contact with the task tracker, and all the things will be stored in the SDFS, right?
Yeah.
Now this is
so,
the
yeah, I mean, the Hadoop 1.2.1, right? That is a single node, right?
yes, that is the Hadoop version 1.
So you are telling that Hadoop 2.0 version is not really
And this is the latest one.
not really.
Yeah, that is the Hadoop 2.0 version is the latest one. Okay. So for going for the Hadoop 2.0 version, first you have to get the understanding of the Hadoop 1.1 version. Okay. Because without having Hadoop 1.1, we will not be able to go for the Hadoop 2.0 version. So see the same thing, whatever you are seeing on the screen, the same picture. Now you may be able to understand this picture. Okay. That is in the case of the Hadoop 1.0 version. Now the same thing will happen in the Hadoop 2.0 version. See what are the different modification is there. See, this is the client node having the MapReduce function, job is there, that is the same. Okay. Now this SDFS is also same. Here this task tracker is also same. Okay. What are the modification you are getting? The modification you are getting here is the first one, that is the resource manager. Okay. And this one, that is the node manager. That are the two modification. When you will install that, then you will get some different configuration, some extra configuration file for MapReduce 2 version. So that we will see later. First we have to go through the MapReduce 1 version. Then we have to do in the case of the advanced MapReduce also we have to write certain programs using the Java. If you people are familiar with the Java, then it's okay. Otherwise we have to go for the next one. The same problem that we are doing with the MapReduce, we can do it with some other technology. Okay, in the case of the Hadoop only, and that technology is also present in the 1 version and 2 version both. Now if you are do you work in the .NET or something like, or the Java, or you are the admin side? You are the analytics side, no?
I am into analytics.
Oh, okay.
Yeah.
Then you might be not be able to write the Java program, something like that. There is no need to worry. Okay. The same program.
Not completely, but yeah. But
so whatever the program we have for writing in the Java, we can write in the other language also. Okay. And the Java program of
that's what you're thinking.
Sorry. So Java program
we can write it in peak.
Yeah, the same thing. Whatever the data we are going to write using the 200 lines, that we can write in the 5 to 10 lines in the peak. So which one is the prefer for you? You can choose.
Yeah, that's great.
Yeah. So that, for that's why I am telling you that we can see that.
You want to give any you want to give any homework for peak knowledge? I mean, before going to peak directly, if you want to give any homework to us to get familiar with peak before you start.
If you want, I can provide you. There is no problem. Anyhow, I have to give you the peak material, na. So if you want, we can send.
Okay.
Okay. That peak can be.
Is there any
work, means programming, something like that?
Go ahead.
Yeah, that programming is included in the advanced MapReduce. Okay, and for that you have to make use of the Java.
Okay.
Okay. If you are familiar, it's okay. If you are not familiar, you can directly join to the Pig 1. Okay. There is no problem in that one.
Another question about the configuration.
You have getting the Wi-Fi now.
So
you need any help in the configuration?
So that so I was using Ubuntu, right? Now I'm not using Ubuntu. I am using Cloudera. Okay. So in Cloudera, the command will be different, right?
Yeah, certain thing will be changed. So how you install the Cloudera?
Okay. So the sudo. So Cloudera setup I just install in the virtual machine.
You can install the
So
Ubuntu.
in the Cloudera already.
Yeah, tell me.
So Ubuntu is not working for me. Yeah, Ubuntu I'm not getting internet, so I I install
You are
Cloudera. So
using the
Cloudera has all
which
this
company dongles? That is a Airtel, MTS, something like that.
MTS.
MTS. That MTS is working in the Windows.
Yeah, yeah.
You are Windows 8 or 7 or something like that.
7.
7. It's fine. It will work. Okay, we will see that later. Before going for that. Okay. So in the next topic we will cover the pig material. Whatever the pig we have, we can see in the next topic. Okay. Just in the Cloudera also, you just follow all the topics. Means how the configuration is done. The same configuration, just try it. If you are getting any problem, we can see tomorrow. Okay.
Yeah, yeah. I think Cloudera is better compared to Ubuntu because Cloudera already has the peak and hype and
Yes, that's what I'm
scoop
telling.
and all.
If you have already everything, then you may be not able to understand with the configuration how it's working, something like that. Okay.
Yeah, yeah. I'll go to the Google page.
Just if you want, you can go to the YouTube. Everything is mentioned there. What is the differences between the Cloudera and Ubuntu, something like that. Okay.
Okay, yeah.
Okay. So see you in the next class. Okay. Hello.